Okay, here we got the crap ripped out of this thing, the diode board, the filter caps, balancing resistors, the filter cap for the bias supply. Here's the diode board, got it clean. Got the parts cleaned up. So we'll clean up the solder connections on this diode board, clean it, test everything, put it back together. Well, that's just part of the excess solder that we took out of this thing. A whole bunch more of it got flicked on the floor or sucked up, but this is why we're doing this. Talk about making a silk purse out of a sow's ear. I guess we'll straighten these leads and test the capacitors and make sure they're okay and reuse them, but man, this is ugly. Well, sometimes you dig into things and find stuff you don't want to find. These are the leads coming out of the high voltage plate leads coming off of the power transformer, and you know, I unsoldered them and I looked at them, they look kind of green. I trimmed them off, get down to some clean wire, and what did I find? A very green, very corroded wire. And I said, well, all right, I'll take a razor blade and try to scrape it a little bit. No dice. Had to untwist it and use deoxit and a paper towel to get the green corrosion off, because the wire is completely full of green corrosion. Yeah, makes you wonder what's happening inside the transmitter or inside the transformer. But anyway, I'll clean up this other lead. I got it clean like this so I can tin it and solder it back onto the diode board here. So, you know, 800, 900 volts AC on there. You don't want a high resistance connection. So that's the kind of stuff you find when you dig into things a little bit. So here we are with the wires cleaned with deoxit and scraped. They're pretty copper colored. You don't really see it in the fluorescent light, but they should take solder now and work okay. Okay, here we got most of the power supply rewired. Cleaned up the diode board. Got these filter caps and resistors in here right. Got reasonably good connections here. Changed a few wires. Placed this wire that runs from the bleeder, runs over here now, and filter choke runs right over here instead of going all the way over here. Got the bias supply in on this little strip with its filter cap in there. Got the leads from the choke from the bias supply. It's going straight through here. Got the resistors up here and away from the capacitors so they can cool a little bit. These wires aren't pinched under the terminal strip anymore. Cleaned up the bias supply wiring a little bit. So this lead will go over here to the from the filter choke to the high voltage terminals on the board, but I got to get the low voltage capacitor in here, so it's gonna glue in here like this. So it's gonna have hot glue on the bottom and hot glue on this surface and here, and get a wire from this point here, the low voltage terminal, over to the capacitor, get the resistor on the high voltage side into ground, and we'll be ready to test this puppy. But anyway, we'll go back and look at the old picture. It's a little bit cleaner than it was. Well, that's how it looks now. Have to go back and compare it to the way it was. But anyway, we got this low voltage filter cap is hot glued to the chassis. and got the bleeder resistor mounted up here. It was convenient to pick up a ground point and tie it to the low voltage right there on that diode board, so we did that. And anyway, I think, can't see very well with those glasses. I don't know what glasses I need, but anyway, I think it's reasonably sanitary, and at least you can follow all the wiring and see all the connections. And that's a solder joint that I didn't do. The other guy did that, and I haven't undone it. Guess I'll leave it alone. I haven't smoke tested it yet, but should be okay. Plug it into the watt meter and turn it on and watch it explode, and put the voltmeter on there and check everything. Same parts it had before. A little hard to make something look really nice when you're rebending leads on components and trying to get the old solder off and make them look good again. But anyway, that's what we got, and I think it's going to be okay. Well, here's a fun thing to do. Here's an infrared thermometer. Let me change hands here. Infrared thermometer, and shoot this little laser beam on here, and we'll see how hot this bleeder resistor gets, and you won't believe it. Well, I saw almost 400 degrees there. Last time I measured it was 318. There we go. 356. There you go. That's how hot this sucker is getting. Mighty hot. So there's almost 400 degrees. I saw 392 there for a minute. Look at that. That explains why when I left the thing on for a couple hours, it was so hot. But the transformers are barely heating up at all. It's cold in here. It's only about 70 degrees or a little less in this room. There's the table temperature, 75, the wall 66. So the, what do you call it, the transformers are barely warming up. I measured the, take a look at my old puss for a minute. I measured the bleeder resistor for the low voltage circuit, and it was only about 100 degrees. And the little balancing resistors across the these balancing resistors across the filter caps in the high voltage section, they're only about 90 degrees or so. This is now a 10 watt 20k resistor, and it was about 100 degrees, not too bad. But that bleeder resistor for the high voltage supply, man, 350 or 400 degrees, no wonder that power supply gets hot. I think this thing will get itself a fan. Got a 220 volt fan, run it on 110. It'll be real quiet, but it'll move some air through there, and I think that's not a bad idea. Keep the rest of the components cool.